Our next proof starts with surjective functions, or onto functions. We'll prove that if A, which goes from A into B, and G, which goes from B into C, are both surjective, or onto, then this composition of functions, G composed with F, which goes from A to C, is also surjective. So as a comment, I put in brackets, we're going to show that for an arbitrary Z in this set right here, there is an X in this set such that G of f of x is equal to Z. And remember, that's just the definition of G composed with f of x. I prefer to see it in that form. Okay, let's prove it. It should be a very straightforward proof. If Z is an element of this set right here, well, do we know anything about that? Well, we do. Notice that G goes from B into C, and it is surjective. Therefore, there's a B, little b, in big B, that maps to this Z in C. I could have used a little c here if I wanted to, but that's too late. I'll keep going. Then, there exists a B in capital B such that G of little b is equal to Z. And one more time, how do we know that? Maybe I'll not put a period there. I'll put in brackets here as the justification, since G is surjective. All right, well, what's that going to tell us? We now have a little b in B. All right, little b in big B. Let A in A, well, let me use X since I used it here. Let X be an element of A be such that f of x is equal to b. How am I allowed to do that? Since f is surjective. F being surjective means that I can choose any little b here, any one in this whole set, and there is some a, little a in this big set A, in capital A, that will map to it. I think that is about all we need. Therefore, G of f of x is equal to, well, f of x is equal to b. And G of B is equal to Z, and we're done. Very simple proof. Just to kind of show you a picture, I'm making these sets of different sizes. So I'm doing that to kind of show that every element of B gets mapped to from something here. You know, maybe it's looks like that, but there's no elements in B that are left out. And that's the function f that goes from A to B. And then from B to C, G will take you from all these elements in B will get mapped to all of the elements in C. So therefore, G of f of x is equal to Z, no matter where Z is in that set C. It'll work for every single little Z in that set C.